All right, students, so we're going to take a look at this first problem. And we have j to the negative 13th power times j to the 4th power times j to the 6th power. What's really good to know is that we're multiplying here, so just knowing the commutative property of multiplication, we can know that we can essentially do this in any order. So what I'm going to do here first is combine these two terms here. Using one of our exponent properties that we can add these two exponents together when we're multiplying the same base. All right, so we're going to get j to the 10th times j to the negative 13th. When we look at j to the negative 13th, immediately we can look at our negative exponent power rule, and we can use this as the reciprocal, so we can change this to 1 over j to the 13th times j to the 10th. I would then go ahead and rewrite this second one as a fraction. It's just 1 over j to the 13th times j to the 10th over 1. And then we can go ahead and multiply straight across. And we can get j to the 10th over j to the 13th. Now we can just use our quotient property. And we're going to, since we're dividing these powers, we're going to subtract the exponents here. So 10 minus 13 is going to give us j to the negative 3rd power. And then again, we will use our reciprocal here for negative exponents. And we will end up with 1 over j to the 3rd. Just want to quickly show you that we can solve this another way as well. What's beautiful about mathematics is as long as you are kind of staying within the confines of that, you have a lot of freedom to solve a lot of these or simplify a lot of these. Another way you could look at this is if these are all over 1, we would know that we would need to take the reciprocal of this j to the negative 13th. So we would get j 1 over j to the 13th times j to the 4th over 1 times j to the 6th over 1. And we would get j to the 4th times j to the 6th over j to the 13th. J to the 10th over j to the 13th equals j to the negative 3rd, which equals 1 over j to the 3rd. All right, students, we're going to look at this next problem. You'll notice that we have some coefficients here that we'll also have to deal with. One thing I recommend, and you can understand this by knowing that the commutative property of multiplication allows us to do this. We can essentially separate these terms into two separate fractions. So we can write this as 24/12 times x to the 6th over x to the negative 8th. Okay, this allows us to kind of work with these coefficients and then our powers here separately. So if we were to simplify 24/12, we're basically just dividing by 12 on the top and bottom here, numerator, denominator. And 12 divided by 12 is 1, and 24 divided by 12 is 2. So we're left with 2 over 1. And then we're just going to go ahead and use the quotient property of exponents. What that basically states is you can, when you're dividing these powers, you can subtract the exponents. So we're looking at x to the 6 minus negative 8. And our rules of integers know that any subtraction problem can be written as an addition problem. And that's sometimes people call it the substitution identity. So really this can be written as x to the 6 plus 8. And so we get x to the 14th over 1. And when you multiply across, we get 2 times x to the 14th over 1, or 2 to the x, 2 times x to the 14th. Same idea here. We have some coefficients here, which can kind of get a little hairy, but it's not a big deal. If we go ahead and separate our fractions out like we did in the previous problem, it makes it a little bit more manageable. So we can get 3/12 times x squared over x to the 6th times y to the negative 3rd over y to the 3rd. Go ahead and deal with this fraction first. 3/12 can be reduced if we're dividing by 3 to 1/4. So we've got 1/4 times, and we'll use the quotient property again here. So this is x squared minus 6 over 1 times y to the negative 3rd minus 3 over 1. Okay, so we've got 1/4 x to the power of 2 minus 6 gives us x to the negative 4th over 1 times y to the negative 3rd minus 3 would give us y to the negative 6 over 1. Okay, and then we know that we need the reciprocal of both of these in order to get rid of those negative exponents. So the reciprocal of x to the negative 4th is 1 over x to the 4th times, same thing here, the reciprocal would be 1 over y to the 6th. And if we multiply straight across, we get 1 over 4x to the 4th y to the 6th. What I like about these problems is we can solve them in a multitude of ways, which is really fun. Some of you may try this problem and do it completely different than I do, which is great. So the first way we can look at this is we can apply the power of power property to each of these terms in here. In addition, we could also just identify that how we're going to solve this is by multiplying this as the reciprocal raised to the second power, if that makes sense. So first way is we could just apply this negative exponent to each of these terms in here. Okay. Secondly, we could also just look at it as 1 over 2x to the 3rd y to the negative 3rd to the second power. Kind of makes things a little bit easier. And by doing that, we avoid, because when we do 2 raised to the negative 2 power, basically what we're saying is how many times are we going to, so 2 squared is multiplication, right? And what do we know about negative? Negative invokes this idea of the opposite. So if we're multiplying here, if this is 2 times 2, basically what we're doing is how many times are we going to divide by 2? So 1, and dividing by 2 is the same as multiplying by 1/2. So how many times are we going to multiply by 1/2 times 1/2 times 1/2? And we get 1/4. As you can see, we get the reciprocal here. It's basically what we're saying. So you could apply that and get 1/4, or we could just apply that we're multiplying. We just take the reciprocal of our original problem and then multiply it by the positive exponent. So this could also be 1 over 2 squared is 4. X to the 3rd raised to the second power is x to the 6th. And y, negative 3rd power raised to the second power is y to the negative 6th. Okay. And then we have a negative exponent on the bottom, So we want the reciprocal of that. So we get y to the 6th over 4x to the 6th. And that's our answer there. All right, let's take a look at our next problem, question 5. Again, we got some coefficients, so we can simplify those. Essentially, we can divide by 2 on the top and bottom. We get 1/4. So we're left with x to the 4th, y to the -4th over 4 times x to the 7th, y to the 3rd. Okay. I see a negative exponent here, so we're just going to move that to the denominator. So we've got x to the 4th over 4x to the 7th, y to the 3rd, y to the 4th. All right. And we'll go ahead and combine these terms here by simply adding those exponents. We get x to the 4th over 4x to the 7th, y to the 7th. So you can look at this in a couple of ways as well. When you have, essentially what you see is we have exponents. We have a greater number of exponents on the denominator than the numerator when we're talking about this quotient property of exponents. You could subtract them and you would get x to the -3rd over 4y to the 7th. We can look at it that way, and then you're basically just bringing it back down to the denominator. Or we can visually just know that if we were just to kind of pull this out, and we had, we could expand this out to x times x times x times x. So that's x to the 4th over x to the 7th, x times x times x times x. Okay. It's basically what we have. And we know that x divided by x is 1, x divided by x is 1, divided by x is 1, x divided by x is 1. So we're left with x to the 3rd on the bottom. So we can just say this is 1 over 4x to the 3rd, y to the 7th. Otherwise, you could just write it as, when you subtracted these, you could get x to the -3rd over 4y to the 7th, and then rewrite it as we have before as 1 over 4x to the 3rd, y to the 7th. Either works. So go ahead and look at our next problem. See, we have a exponent here out on the outside of the parentheses. One of the big mistakes students may make is that they only apply this exponent to these terms here. But what you also have to remember is this exponent also applies to this 4. So the 4, the x to the 4th, and the y to the -4th all need to be raised to that power of 3. So we'll just go ahead and apply that. And we get 4 to the 3rd times x to the 4th, x to the 12th, y to the -12th. Okay. You see that we have a negative exponent here in the numerator. So we're going to go ahead and simplify this or rewrite it as 4 to the 3rd power x to the 12th over y to the 12th. Then we're just going to have to evaluate 4 to the 3rd. Well, 4 times 4, this is 4 times 4 times 4. 4 times 4 is 16, times 4 is 64. So we get 64 x to the 12th, y to the 12th. Okay, so this next one is looking pretty complicated, but that's okay. First thing we notice is that this entire problem here is raised to the -4 power. So essentially this -4 is going to be applied to each term in the numerator and the denominator. Okay, and we're going to get a bunch of negative exponent values here by doing that. One thing we can, if we understand, is that we can essentially multiply this entire fraction by its reciprocal raised to the fourth power. So essentially we could rewrite this as 3a, I'm writing the denominator here, to the third power, b to the fourth power, c to the third power, over negative 7a squared, b to the third power, c to the 0 power. And we can raise that now to the fourth power instead. So essentially, we take the reciprocal and multiply it, or raise it to the fourth power instead of the negative fourth power. And then we go ahead and apply that exponent to each term in the parentheses. So we get 3 to the fourth power times a to the 12th power times b to the 16th power times c to the 12th power over negative 7 to the 4th power, a to the 8th power, b to the 12th power, and 1, c to the 0 power is equal to 1. So you could say it's 1 to the 4th power, which would be 1, or you could say it's c to the 0 power times 4. 0 times 4 is 0, so you still just get 1. So we can just leave that blank. Okay, from here we're going to start simplifying. We can separate these out. So why don't we take our integers here? We could just say this is 3 to the 4th over negative 7 to the 4th times a to the 12th over a to the 8th times b to the 16th power over b to the 12th power times c to the 12th power over 1. Okay. We can just go through and start simplifying these. So a to the 12th, so we're looking at 12 minus 8. So we get a to the 4th power over 1 times 16 minus 12 would also be b to the 4th power over 1 times c to the 12th power over 1. And now we need to go ahead and evaluate these. So negative 7 to the 4th power is essentially negative 7 times negative 7 times negative 7 times negative 7. And as we evaluate that out, we would get a positive 2,401. And in the numerator, we have 3 times 3 times 3 times 3, which is equal to 9 times 9, which is 81. Then we just go ahead and recombine this. And we get 81 a to the 4th, b to the 4th, c to the 12th over 2,401. All right, students, again, we have another problem here we'll take a look at. Same idea as the last one. You can go ahead and apply this negative 2 exponent to each value inside the parentheses, both numerator and denominator. But we can also understand that we can take the reciprocal and raise that to the opposite of the negative 2 exponent here. So we could essentially rewrite this as the denominator on top is 3a squared b to the 3rd c to the 7th over negative 2a to the 3rd b squared c to the 0 power, and raise that to the 2nd power. Makes life a little simpler. And then we go ahead and apply this exponent to each term here. Don't forget your coefficients. So this would be 3 squared. A, remember we're multiplying because we're raising a power to a power. A to the 4th, B to the 6th, C to the 14th power, over negative 2 squared, A to the 6th, B to the 4th. And then 0 times 2 is 0. And we know C, or any number raised to the 0 power, is 1. So we can just leave that blank. Okay. So now we can go ahead and separate this out. So let's say we have 3 squared over negative 2 squared times A to the 4th over A to the 6th times B to the 6th over B to the 4th times C to the 14th over 1. We can evaluate these here. So we have, let's start here, A to the 4th over A to the 6th. That's equal to A to the 4 minus 6. And this is equal to B to the 6 minus 4. And this is just C to the 14th. So 4 minus 6 would be A to the negative 2 over 1 times B squared over 1 times C to the 14th over 1. 3 squared is 9. Negative 2 squared is 4. All right, now we can just multiply across and combine these back. And we get 9 times A to the negative 2 times B squared times C to the 14th all over 4. Just remember we have this negative 2 here in the numerator, and we need that to be in the denominator. And I've showed this before. We can simply just move it down to the denominator here. But essentially how we're doing that mathematically is multiplying by a value of 1, A squared times A squared. And when you use the product property of exponents here, you would get A to the negative 2 plus 2, which equals A to the 0 power, which equals 1. So we're left with 1 here. And we get 9B squared C to the 14th all over 4 times A squared. So as we're looking back at this problem, another way you could look at this is before you're about to combine all these back. What would be helpful, and what most of you should do, is you should look at this and immediately say, oh, I need the reciprocal of that. So then you multiply by 1 over A squared. That way when you multiply across, you get 9B squared C to the 14th all over 4A squared. Right away, instead of having to look back on this way and think through kind of my thinking of how you would move that negative exponent to the denominator.